IPsec interfaces with the TCP UDP transport layer and the internet layer, and is applied transparently to applications. IPsec is transparent to users as well. This basically means that IPsec can provide security for most of the protocols within the TCP/IP protocol suite. When it comes to applications, all applications that use TCP/IP can enjoy the security features of IPsec. You do not have to configure security for each specific TCP/IP packet-based application. By using rules and filters, IPsec can receive network traffic and select the required security protocols, determine which algorithm to use, and recall cryptographic keys required by any of the services. The security feature and capabilities of IPsec can be used to secure the private network and private confidential data from the following: denial of service, DOS attacks, data pilfering, data corruption, theft of user credentials. The security functions and features provided by IPsec are summarized below. Point 1. Authentication. A digital signature is used to verify the identity of the sender of information. IPsec can use Kerberos, appreciated key, or digital certificate for authentication. Point 2. Data integrity. A hash algorithm is used to ensure that data is not tampered with. A checksum called the hash message authentication code, HMAC, is calculated before for the data of the packet. When a packet is modified while in transit, the calculated HMAC changes. This change will be detected by the receiving computer. Data privacy encryption algorithms are utilized to ensure that data being transmitted is undecipherable. Anti-replay prevents an attacker from resending packets in an attempt to achieve access to the private network. Non-repudiation. Public key to digital signatures are used to prove message origin. Dynamic rekeying. Keys that can be created during data sending to protect segments of the communication with different keys. Key generation. The Diffie-Hellman key agreement algorithm is used to enable two of the computers to exchange a shared encryption key. IP packet filtering. The packet filtering capability of IPsec can be used to filter and block specific types of traffic based on either of the following elements or a combination of them: IP addresses, protocols, ports. How IPsec works. An IPsec-enabled server or host contacts client computer for a list of ciphers and algorithms that both devices support. Once the cipher has been chosen, the client decrypts any data that is sent by using that specific algorithm, so that only the server can decrypt the data by using the agreed-upon public key. The IPsec-enabled server will then re-encrypt any data that is sent back to the client in the same manner. The two devices will communicate in this way until the session has closed. A security association (SA) has to first be established between two computers before data can be securely passed between the computers. A security association (SA) is a relationship between devices that define how they use security services and settings. The SA provides the information necessary for two computers to communicate securely. Internet Security Association and Key Management Protocol (ISAKMP) and the IKE protocol are the mechanism that enables two computers to establish security associations. When an SA is established between two computers, the computers negotiate on which security settings to utilize secure data. A security key is exchanged and used to enable the following to communicate securely. The Security Association SA contains the following. Point 1. The policy agreement, which dictates which algorithms and key lengths the two computers will use to secure data. Point 2. The security keys used to secure data communication. Point 3. The security parameter index, SPI. With IPsec, two separate SAs are established for each direction of data communication. One SA secures inbound traffic. One SA secures outbound traffic. In addition to the above, there is a unique SA for each IPsec security protocol. There are therefore basically two types of SAs. ISAKMP SA, when traffic flow is two-directional and IPsec needs to establish a connection between computers. An ISAKMP SA is established. The ISAKMP SA defines and handles security parameters between the two computers. The two computers agree on a number of elements to establish the ISAK-PMP-SA. Determine which connection should be authenticated. Determine the encryption algorithm to use. Determine the algorithm to verify the message integrity. After the above elements have been negotiated between the two computers, the computers use the Oakley protocol to agree on the ISAK-MP master key. This is the shared master key which will be used with the above elements to enable secure data communication. After a secured communication channel is established between the two computers, the computers start to negotiate the following elements. Determine whether the authentication header IPsec protocol should be used for the connection. Determine the authentication protocol which should be used with the protocol for the connection. Determine whether the Encapsulating Security Payload IPsec protocol should be used for the connection. Determine the encryption algorithm which should be used with the ESP protocol for the connection. IPsec SAs pertain to the IPsec tunnel and IP packet and define security parameters to use during the connection. The IPsec SA is derived from the above four elements, just negotiated between the two computers. To secure and protect data, IPsec uses cryptography to provide the following capabilities. Point 1. Authentication. Authentication deals with verifying the identity of the computer sending the data, or the identity of the computer receiving the data. The methods which IPsec can use to authenticate the sender or receiver of data are digital certificates, provides the most secure means of authenticating identities. Certificate authorities, CAs, such as Netscape, Untrust, VeriSign, and Microsoft provides certificates which can be used for authentication purposes. Point 2. Kerberos authentication. The downside of using the Kerberos version 5 authentication protocol is that the identity of the computer remains unencrypted up to the point that the whole payload is encrypted at the authentication. Pre-shared keys should be used when none of the former authentication methods can be used. Anti-replay ensures that the authentication data cannot be interpreted as it is sent over the network. In addition to authentication, IPsec can provide non-repudiation with non-repudiation. The sender of the data cannot, at a later stage, deny actually sending the data. Data integrity deals with ensuring that the data received at the recipient has not been tampered with. A hashing algorithm is used to ensure that the data is not modified as it is passed over the network. The hashing algorithms which can be used by IPsec are message digest MD5, a one-way hash that results in a 128-bit hash which is used for integrity checking. Secure hash algorithm 1, SHA1, a 160-bit security key, secret key to generate a 160-bit message digest which provides more security than MD5. Data confidentiality. IPsec ensures the data confidentiality by applying encryption algorithms to data before it is sent over the network. If the data is intercepted, encryption ensures that the intruder cannot interpret the data. To ensure data confidentiality, IPsec can use either of the following encryption algorithms. Point 1. Data encryption standard, DES. The default encryption algorithm used in Windows Server 2003, which uses 56-bit encryption. Triple DEC, 3DES. Data is encrypted with one key, decrypted with another key, and encrypted again with a different key. 40-bit DES, the least secure encryption algorithm. Understanding IPsec terminology. This section of the article lists the commonly used IPsec terminology and concepts. Point 1. Authentication Header, AH. This is one of the main security protocols used by IPsec. AH provides data authentication and integrity, and can therefore be used on its own when data integrity and authentication are relevant factors, and confidentiality is not. This is because AH does not provide for encryption, and therefore cannot provide for data confidentiality. Authentication Header, AH, and Encapsulating Security Payload, ESP, are the main security protocols used in IPsec. These security protocols can be used separately or together. Encapsulating Security Payload, ESP. This is one of the main security payloads, security protocols used by IPsec. ESP ensures data confidentiality through encryption, data integrity, data authentication, and other features that support optional anti-replay services. To ensure data confidentiality, a number of systematic encryption algorithms are used. Certificate authorities, CAs. This is an entity that generates and validates digital certificates. The CA adds its own signature to the public key of the client. CAs issue and revoke digital certificates. Diffie-Hellman groups. Diffie-Hellman key agreement enables two computers to create a shared private key that authenticates data and encrypts an IP datagram. The different Diffie-Hellman groups are listed here. Point 1. Group 1 provides 768-bit key strength. Group 2 provides 1024-bit key strength. Group 3 provides 2048-bit key strength. Internet Key Exchange, IKE. The IKE protocol is used by computers to create a security association, SA, and to exchange information to generate Diffie-Hellman keys. IKE manages and exchanges cryptographic keys so that the computers can have a common set of security settings. Negotiation occurs on which authentication method, an encryption algorithm, and hashing algorithm the computer will use. IPsec Java performs a number of operations to enable secure network communication, including the following: creates IPsec packets, generates checksums, initiates the IKE communication, adds the H and ESP headers, encrypts data before it is transmitted, calculates hashes and checksums for incoming packets. IPsec policies define when and how data should be secured, and defines which security methods to use for securing data. IPsec policies contain a number of elements: all actions, rules, filter lists, filter actions. IPsec policy agents. This is a server running on a computer running Windows Server 2003 that accesses IPsec policy information. The IPsec policy agent accesses the IPsec policy information in either the Windows registry or an Active Directory. Oakley Key Determination Protocol. The Diffie-Hellman algorithm is used for two authenticated entities to negotiate and be in agreement on a secret key. Security Association, SA. SA is a relationship between devices that define how they use security services and settings. Triple Data Encryption, 3DES. This is a strong encryption algorithm used on client machines running Windows and on Windows Server 2003 computers. 3DES uses 56-bit keys for encryption. Understanding the IPsec modes. IPsec can operate in one of the following modes. Point 1. Tunnel mode. IPsec tunnel mode can be used to provide security for WAN and VPN connections that use the internet as a connection medium. In tunnel mode, IPsec encrypts the IP header and the IP payload. With tunneling, the data contained in the packet is encapsulated inside the additional packet. The new packet is then sent over the network. Tunnel mode is typically used for the following configurations: server to server, server to gateway, gateway to gateway. The process of communication that occurs when tunnel mode is defined as the IPsec mode is detailed below. Data is transmitted using unprotected IP datagrams from a computer on a private network. When the packets arrive at the router encapsulates the packet by using IPsec security protocols. The router then forwards the packet to router at the other end of the connection. This router checks the integrity of the packet. The packet is decrypted. The data of the packet is then added to unprotected IP datagrams and sent to the destination computer on the private network. Transport mode. This is the default mode of operation used by IPsec, in which only the IP payload is encrypted through the AH protocol or ESP protocol. Transport mode is used for the end-to-end communication security between two computers on the network. Many networks which are not able to support tunnel mode are able to successfully support transport mode. Understanding the IPsec protocols. The main IPsec security protocols are the Authentication Header (AH) and Encapsulating Security Payload (ESP) protocols. There are other IPsec protocols such as ISAK-MP, IKE, and Oakley that use the Diffie-Hellman algorithm. Authentication Header (AH) protocol. The AH provides the following security services to secure data: authentication, anti-replay, data integrity. The AH protocol ensures that data is not modified as it moves over the network. It also ensures that the data originates from the sender. The AH protocol does not, though, provide data confidentiality because it does not encrypt the data contained in the IP packets. This basically means that if the AH protocol is used by itself, intruders that are able to capture data would be able to read data. They would not be able to change the data. The AH protocol can be used in combination with the ESP protocol if you need to ensure data confidentiality as well. The communication process which occurs when the AH protocol is used is shown here. One computer transmits data to another computer. Point 2. The IP header, AH header, and the data itself is signed to ensure data integrity. Point 3. The AH header is inserted between the IP header and IP payload to provide authentication and integrity. The fields within the AH header, together with the role performed by each field, is listed here. Next header, used to specify the type of IP payload through the IP protocol ID that exists after this AH header. Length indicates the length of the AH header. Security Parameter Index, SPI, indicates correct security association for the communication through a combination of the following: IPsec security protocol, destination IP address, sequence number, used to provide the IPsec anti-replay protection for the communication. The sequence number commences at 1 and is incremented by 1 in each ensuing packet. Packets that have the same sequence number and security association are discarded. Authentication data holds the integrity check value (ICV) calculated by the sending computer to provide data integrity and authentication. The receiving computer calculates the ICV over the IP header, AH header, and IP payload, and then compares the two ICV values. Encapsulating Security Payload, ESP protocol. The ESP protocol provides the following security services to secure data: authentication, anti-replay, data integrity, data confidentiality. The primary difference between the AH protocol and the ESP protocol is that the ESP protocol provides all the security services provided by the AH protocol, together with data confidentiality through encryption. ESP can be used on its own and can be used together with the AH protocol in transport mode. The ESP protocol only signs and protects the IP payload. The IP header is not protected if the ESP protocol is used together with the AH protocol, then the entire packet is signed. ESP inserts an ESP header and ESP trailer, which basically encloses the payload of a DIP datagram. All data after the ESP header to the point of the ESP trailer, and the actual ESP trailer is encrypted. The fields within the ESP header, together with the role performed by each field, are listed here. Point 1. Security Parameters Index, SPI, indicates the correct security association for the communication through a combination of the following: IPsec security protocol, destination IP address, sequence number, used to provide IPsec anti-replay protection for the communication. The sequence number commences at 1 and is incremented by 1 in each ensuing packet. Packets that have the same sequence number and security association are discarded. The fields within an ESP trailer, together with the role performed by each field, are listed here. Padding, required by the encryption algorithm to ensure that byte boundaries are present. Padding length indicates the length bytes of the padding which was used in the padding field. Next header, used to specify the type of IP payload through the IP protocol ID. Authentication data, OSI integrity check value ICV, calculated by the sending computer to provide data integrity and authentication. The receiving computer calculates the ICV over the IP header, AH header, and IP payload, and then compares the two ICV values. IPsec and ISAKMP. IPsec relies on ISAKMP, Internet Security Association and Key Management Protocol for key exchange. FreeS WAN IPsec. FreeS WAN is an implementation of IPsec and IKE for Linux. The primary objective of the FreeS WAN project is to help make IPsec widespread by providing source code which is freely available, runs on a range of machines, including ubiquitous cheap PCs, and is not subject to US or other nations' export restrictions. Understanding IPsec security filters, security methods, and security policies. Security filters basically match security protocols to a specific network address. IPsec filters can be used to filter out unauthorized traffic. The filter contains the following information: source and destination IP address, protocol used, source and destination ports. Each IP address contains a network ID portion and a host ID portion. Through security filters, you can filter traffic according to the following: traffic allowed to pass through, traffic to secure, traffic to block. Security filters can be grouped into a filter list. There is no limit to the number of filters which can be included in a filter list. IPsec policies uses IP filters to ascertain whether an IP address, whether an IP security rule should be used in a packet. You can use a security method to specify the manner in which an IPsec policy should deal with traffic matching an IP filter. Security methods are also referred to as filter actions. The filter actions result in either of the following events: drops traffic, allows traffic, negotiates security. To apply security in your network, IPsec policies are used. The IPsec policies define when and how data should be secured. The IPsec policies also determine which security methods to use when securing data at different levels in your network. You can configure IPsec policies so that different types of traffic are affected by each individual policy. IPsec policies can be applied at the following levels within a network: Active Directory domain, Active Directory site, Active Directory organizational unit. Computers, applications, the different components of an IPsec policy are listed here. IP filter informs the IPsec driver on the type of inbound traffic and outbound traffic which should be secured. IP filter list, used to group multiple IP filters into a single list in order to isolate a specific set of network traffic.